Welcome! This video will take the PowerBasic Console Compiler code we prepared in our last video and add some more advanced string handling and sorting in arrays, as well as writing the arrays to file. This is the PowerBasic Console Compiler application we looked at in previous videos. This code reads one file, line by line, and conditionally outputs information to a second file. Today what we're going to do, rather than read it line by line, we're going to read the entire file into an array at one go, and then perform operations on the array itself before outputting the array back to a file. So, rather than the function we had here, which read the file and output, what we're going to do here is we're going to read the file into an array. Now, if we're going to do this, we'll still need to know where the file is, so my file is still quite relevant. We'll also want to treat it as a function because we want to get the value back. There we go. Now, if we're going to read it into an array, we obviously have to have an array to read it into. So we will dimension array up here, and we'll just call this strwork. Now, we haven't actually dimensioned the size of the array, we've just actually given it a name, and that is what we're going to pass to our function. Now, doing it this way, we're actually passing a reference to where the area in memory is, and we're going to let our new function redimension the array to the size we actually need and return true if it actually works. And we can put our post-production code down here. So let's create this new function, and we'll put it into our library of useful functions. Right, in here we will put it as, let's see, str file name perhaps. And what we're going to do here is this. Now, I'm putting the byref in just really for documentation purposes. Strings in PowerBasic are normally passed by reference anyway, but this just makes it obvious that this string array we're bringing in has already been dimensioned somewhere else, and we're passing a pointer in, and effectively this is what we're going to be using. So, having got that in, we'll just put a comment to see what it is. Read the file into an array. Change your spelling. Now, obviously what we're going to have to do in here is we are going to have a file handle because we're going to have to open the file. So let's just set up our file handle as we did in the previous video. And the last one just to give us a file handle for it. Now we're going to put our usual try catch functions in. Now in here we can attempt to open the file. This will attempt to open the file that's been passed in to the function. Now, we haven't dimensioned the array yet, because at this point we don't know how big the file is. It could have 5 records in it, it could have 5 million records. So what we're going to do, as we did the other day, we're going to do a file scan. And we're going to store the number of records we find in the file in another variable, which we will dimension up here. called long records. This will tell us exactly how many records there are in the file. And now that we know how many records in the file, we can redimension the array with the number of records. So that redim command would effectively redimension the array in its location in memory by however many records we actually find in the file, be it 5 or 5 million. Now what we can do is we can do a line input, and rather than read it one line at a time into the array, we're going to read it in en masse. Again, we need a pointer to the file, and all we need then is the name of the array we're actually reading into, and this will read the entire file into that array. Now, we're not explicitly telling it how many records to write into that array. Say, for example, the long records was 5,000 and you only wanted the first 1,000 records in there, then line input does give you the option of actually bringing in, let's bring this up, and we will look at line input. There we go. That construct of the line will let you bring in a number of records, so you don't have to bring in them all, but what we're actually trying to do here is to bring them all in. So if you don't give it any values, then it'll bring them all in. So if this works, then our function will be true. If it doesn't work, then we will, as normal, we'll put something out to the console with whatever the error happened to be, and eventually we will then close the file handle. So what this should do is this should read a file, scan it for the number of records, working on the assumption that the records have a carriage return line feed at the end of each line, which is fairly normal. It will put them all into this str work array. It will then read them all in and pass back either a true or false. If it passes back true, we know it's worked, and in our main calling routine we'll arrive at this point. Now what we can do, just for the sake of knowing how many records we actually got in, we can then print out to the console the number of records. Now we know the array, and what we're going to do is a command called ubound, the upper bound. This will tell us how many records there are, how many elements there are in that array. Now again, this will be a number, so we're going to turn it into a string so we can actually see it. Now assuming we've done everything correctly here, this should compile cleanly. Unfortunately not, because we haven't actually said what we're returning from the function. Correct that minor detail. Let's try running now. What have I missed out here? Have I missed a comma? Yes, I think I missed a comma. And try running now. And we're in. So there we go. It has come back to say it's worked, and it's told us there are 15 records in the file. Excellent. So now that we actually have all the values that we're interested in the file, we can then decide what we want to do with them. Now, what we want to do in this case is we will want to perhaps sort the information. Now, if we look at the information we've actually got in the file, here it is. Same as we had before. I've added a few more lines, but the same number of columns as we had before. First name, surname, address, telephone, and eye colour. Now, if we wanted to sort it just as it stands, we can sort it basically just in the array without doing anything else at all. So what we will do is we will do an array sort. Now the array sorts are a powerful command. If we bring up the help on the array sort, you will see that it can do a lot of different things. The array we're dealing with here is a very simple array. It's a single element array. and it's a string array. So the sorting of multi-dimensional arrays is a bit more complicated, and we'll cover that in a later episode. But as far as sorting string arrays, it is really quite straightforward. All you really need to do is this. So it's array sort, the name of the array, which we know up from here. Collate uppercase just means it's doing its collation based on everything being uppercase, so that all the lowercase a's and uppercase a's sort correctly. Now, we might want an ascending one, and if we do that, it will resort the array in memory. Now, after that, we might want to actually dump the array out to file. So, to do that, I think we want a nice generic array dumping routine, which will take any array we have and dump it out. And we're going to call this one array dump. This is going to take two parameters. It's going to take the name of the file, and it's going to take the name of the array. The file being the output file, and the array being the one we want to dump out to file. So, since we know that, we will obviously want to open a file. So we need a file handle. So we will put in our file handle, and we'll put in a working variable called long R, and we will do the usual. We will attempt to open our file for output. So we pick up the file handle, the next one Windows will give us, the long file. We start the try, we open the file we've been given for output using that handle. Now, assuming that doesn't have any issues and works correctly, what we can do next is we can do a for next loop. Now, the for next loop will take the first element of the array to the last element of the array. Now, what we haven't covered yet is when you dimension array in many versions of BASIC, it uses 0 element. So it starts the first element of the array as 0. So you would be talking as 0 being the first element of the array. Now you can dimension arrays so that they start at 1, but we're going to start at 0. So if this function is going to be generic, it would be handy if it would work out for itself what was the lowest bounding of the array and the upper bounding. And there are indeed two commands to actually let us do this. Lbound, which gives us the lowest bound. So if it starts at 0, it tells us 0. If it starts at 1, it gives us 1. If it starts at 100, it will come back as 100. And ubound, which we've already used before, tells us the upper bounding of the array. So it's going to go in this case from 0 to the upper bounding. Now we know the upper bounding is 15 because we got that when we ran it earlier. So what we want to do then is for each element in the array, we basically want to print out to long file, which is our output file, the long R element in the strwork array. Now this generic function, if we've keyed it in correctly, should actually dump an array out to file. So if we're going to do that, let's just steal this piece of code, go back to here, and we're going to dump it out. Now we haven't actually told it what the output file is, so let's say we're going to have the output file as we had it in the last video. And the array which we've created is strwork, which is fine. Now, we may want to test if this worked or not. So in our function it will either return true or false. So what we haven't done in here is finish off the code. So function equals true. If it gets that far, everything's fine. If it hits some kind of error, the function we want to make false, and we will throw out to the console whatever the error happens to be. And finally, most importantly, we will close off the file handle and end the try statement. So that should be okay. We go back to original code, so if it's true, then we can then print out array saved. Not saved. So what are we doing here? We're actually reading our file in, and we are sorting the array based on all the characters that are in it. Now, as we saw, the file itself, if we look back at the file, has in it this. So it's going to sort on this. Now you can see from this that obviously it will look down here to find that this line is going to be the first one it finds, because it sorts to the top since it begins with A. Now that gives us a problem with the title line. Now ideally we don't want to sort the title line, we want the title line to remain there. So one of the options on array scan, array sort, is telling it which line to begin at. So if we have a look at that, what we can do in here, if we look down to it, it says down here it gives us an example. So if you give a number for the array, it sorts from that element onwards. So we're basically wanting to sort it from number 1. So let's put number 1 in there. So it should leave the 0 element alone. So if we try compiling that, check our syntax, we've got it right this time. If we try running it, remembering it's going to be sending a file to output file, and it says it's saved. So let's have a look at output file to see what we got on it. There's our output file. If we open it up, we have a blank line after first name, which I'll need to check on, but otherwise it has actually sorted the entire file correctly based on the first character and every character after it. So there we have a successful sort of a file. Right, I think I know why we're getting an extra blank line in. When we actually read through the file, when we read it into an array, we're looking to see how many elements we actually find, and we find 15. And at that point we're redimming the array with 15 in there. Now effectively what that's doing, it's effectively doing that 0 to 15, which effectively, as you'll know, is actually 16 records. So all we need to do is that to make sure it's one less. And if we run that now, it says 14. If we come out and look at our file, there we go, no blank line. No line at the end. Success! So I think that will complete this video. Thank you for watching.